and important questions from MS Chouhan's Organic Chemistry, Aldehydes and Ketones, level 1, and the question from 31 to 40. Come on, let us discuss the first question here. Compound A, that is C16H16, combined with ozone, that is called ozonolysis. So, compound A, C16H16, combined with ozonolysis, you are getting the product to be, what do we call, that is the compound name, compound, it is molecular formula C8H8O. Right. Now, C8H8O, it's a compound B. Now, this is a compound A and this is a compound B. This is undergoing the reaction with NH2NH2. So, what is the NH2NH2? Hydrazine along with OH minus. This is OH minus, no? While heating, you are getting the compound. It is ethyl benzene. Right. I hope you got that idea. Okay. So, ethyl benzene. So, this is ethyl benzene. Also, we can say commonly alkane. Right. Alkane, actually, we are getting as a product. Right now, this is a compound B. From that compound A, we are getting the product. So, this might be carbonyl compound. Carbonyl compound. Why do we say it's a carbonyl compound? Because we are using NH2NH2, that is along with basic medium while heating. This is Wolff-Kishner reduction. Wolff-Kishner reduction. So, Wolff-Kishner reduction, what is the duty of Wolff-Kishner reduction? Carbonyl compound converted to alkane. That is only the Wolff-Kishner duty. Right now, we got that idea. This is a key they have given, that is NH2NH2 along with basic medium while heating. So, that is a key point we got it. So, from that only we can get that idea. So, here compound B, it is C8H8O. So, let us check whether it is correct or not. Generally, here what is the product they have given? Here, what it is? Benzene along with 2-methyl group, that is ethyl benzene. Right. So, that means C6H5, CH2, CH3. Right now, here pH, here C, here CH3, double bond O. That means here benzene means C6H6, whereas some other group combined together, benzyl, right, phenyl, right. Okay, so here phenyl only we can bring it. So here phenyl means what it is? C6H5. So C6H5, here C double bond O, here CH3. That means here 6, 7, 8, yet C8, H, how much? Here 5 plus 3. 8. So, C8H8O. Yes, we got it. Or else, it might be aldehyde. This is a keto group. Aldehyde, what it is? Here, C6H5, CH2, CHO. So, that means here 6, 7, 8. C7, C8. H here 5, 6, 7, 8. C8H8O. Yes, aldehyde or ketone. It converted to alkane. That is that Wolff-Kishner reaction. You know very well. Okay, now what is that question? What they have given? What is the reactant A in the question? What is that reactant? Reactant, it is C16H16 only, right? So C16H16, as we are getting the product, what it is? This is through ozonolysis. Here C8H8O. So that means this might be pH. Here C. Here CH3, C double bond O, or this is actually here C, here what it is? pH, here CH3. Right. Now, as undergoing that reaction, ozonolysis, oxygen has removed from here means what is the product you will receive over here? So, here what is it? pH, here C, here CH3, and the same way double bond C, here pH, here CH3. So, how many carbon will be available? Here C6H5, here CH3, that means 6, 7, 8. And the same way 6, 7, 8. 8 plus 8, 16. Right. Okay. And then another one, what it is here? 6, 7, 8. Here also. And the same way hydrogen, it is 5 plus 3. 8 here, 5 plus 3. So 8 plus 8, 16. So that means this is actually this compound, that is both the side phenyl. This might be here cis compound or trans compound. pH, C, here CH3. Double bond C, here pH, CH3, or else here pH, here C, here CH3, double bond C, here CH3, here pH. So diagonally. So this is a trans compound, this is a cis compound. Right now this is cis and this is trans. So this might be both. So that is what, say 16H16. Now both you got compensated with this. Right now, what is the correct option you will get? So here actually option B, or reactant A only they are asking, right? So pH, CH3. Here option B also it is correct. pH, CH, cis and trans both will be correct. Here this won't be correct. Why you know? Because ozonolysis, it is like oxygen keto group, right? That is what keto group or aldehyde group. Oxygen it has to remove. So this might be compound C or compound B. Okay, that means both the compound, option D, it is both B and the C. So option B is the correct option. Hope you got the clarity. See, here only they have given the small key. From that only we can get that idea. Wolff-Kishner reduction, what is the main point you have to consider here? Wolff-Kishner reduction converts aldehyde, that means carbonyl compound converted to alkane, that is done by Wolff-Kishner reduction. Hope you got the clarity. Here is the key for you to find this answer. Come on, let's go to the next question. Hydrogen peroxide undergoing the reaction with H3O+, that is acid hydrolysis, you are getting the product what it is C7H14O2. C7H14O2 will be answerable for iodoform test, 2,4-DNP, that is 2,4-dinitrophenylhydrazine, and also it will be answerable for CrO3, that is chromium anhydride, right, Jones reagent. So these are all will be answerable for C7H14O2. Right now, what kind of a compound it might be? So they have given the key. From here only we can identify. So first and foremost, this will be answerable for iodoform test. Iodoform test. So iodoform test will be answerable for carbonyl compound. That is what it is, methyl keto group, right? This is methyl keto group, CH3, C double bond O, C H2, like this. So first group, starting only you will get that methyl keto group. And the second one, what it is, 2,4-DNP. So 2,4-DNP also here itself I'll mention here, 2,4 dinitrophenylhydrazine, that is 2,4-DNP. So 2,4-DNP test also will be answerable for what it is, methyl keto group, right? Methyl keto group, right? Now here also I'm mentioning here only so that it will be easy for you to identify. Here iodoform test will be answerable for methyl keto group. So both will be answerable for methyl keto group means, yeah, in this option everywhere methyl keto group is available. So here also methyl keto group is available, here also methyl keto group is available, here also methyl keto group, and the last one here also. That means another one more key what they mentioned, positive test for chromium anhydride. See, chromium anhydride will be answerable for whom you know, primary alcohol. Okay, I just mentioned CrO3. It is nothing, chromium anhydride. It is answerable for primary alcohol. So primary alcohol only it will be answerable. So primary alcohol means what is it actually here? Actually in this point here it is actually secondary alcohol. Right, this is CHOH, it's a secondary alcohol. This also secondary alcohol. See, from the key only we can identify. And this is actually what it is, tertiary, CH3, CHOH. So this actually what it is, tertiary alcohol. So this also will not be applicable. So this is a primary alcohol. So primary alcohol means we need a proof. We cannot simply judge primary alcohol will be answerable for so and so. We cannot judge like that. We need a proof. Yes, let us go for that proof to identify option C is the correct. Understand? Actually, this is a proof whether compound C it is answerable or not. Right now here 1-methyl cyclohexyl hydrogen peroxide combined with H3O+. H3O+, it is nothing actually what it is, acid hydrolysis. First H+ ion which is going to attract it towards what it is, lone pair of electrons. So you will be releasing water molecule H2O. So that hydrogen which is combined, so you will get hydrogen H2O. So water molecule releases, then you will get what it is, ethyl compound along with carbocation. So this is ether no O. Only one oxygen along with that hydrocarbon. So ethyl compound along with what it is, positive charge, carbocation. So carbocation, here also water molecule H3O+, right? H3O+. In that one hydrogen which is going to attack that lone pair of electron. Water molecules, this lone pair of electrons attracted towards the positive charge. So you will get another one more compound. This is ether also it is available. And another one more point, what it is, hydroxyl group also available. This OH is there, no. So this OH which is going to attach over here. So that means ether along with OH, what do we call? It is a hemiacetal. So this oxygen and OH combined together. That's what I just mentioned here. So this is hemiacetal. Right, hemi means half. So hemiacetal OH. Right now here again, what happened here? Releases that H+ ion protonated point. So that means hydrogen which is releasing over here. So you will get what it is, O- cation form, anion formation takes place. So anion formation again, hydrogen it is attached. So you will get OH compound. Right now hydroxyl group which is attached while reacting with water molecule. So you will get what it is. This is methyl keto group it is forming. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, and then here what you will be getting. So methyl group also it is available, as well as here what it is, primary alcohol also it is available. So primary alcohol will be answerable for what it is, chromium anhydride CrO3 is also known as Jones reagent. Right. I hope you got the clear idea. Why do we go for this reaction? Because this is the only differentiate from other alcohol. Other thing, everything it is methyl keto group everywhere available. But only this C answer only, which is makes us to differentiate from here. Why? Because Jones reagent is the test for to identify primary alcohol. So that is the reason we have observed this, and option C is the proof. Now it is option C is the correct answer. You are believing right. I hope you got the clarity. How do we get the option? And it is like a long process. That is what I just draw the what it is answer proof for you to understand. I hope you got the clarity. Come on, let's go to the next question. They are asking in this question, correct order of reactivity following compounds towards Grignard reagent. Okay, Grignard reagent is actually nucleophilic addition reaction. That is what very clearly I have given these ideas for you to understand. Grignard reagent is also known as nucleophilic addition reaction. Okay, now let us check the option and the reactivity order. Here this is acetaldehyde CH3CHO and this is formaldehyde HCHO and this is acetophenone, right? CH3, double bond was C6H5, right? Now, in that, which is more reactive, which is less reactive? Let us check. See, whenever we are going for nucleophilic addition reaction, Grignard reagent is one of the nucleophilic addition reaction. So, even OH minus, it is a nucleophilic addition reaction, electron rich. So, whichever nucleophilic addition reaction, which will be go through these ideas. So the reactivity is directly proportional to electrophilicity, that is positive carbon, right? So carbocation. So nucleophilicity, that is reactivity is directly proportional to electrophilicity, and reactivity is indirectly proportional to steric hindrance, right? More carbon atom together in that point. And next one here, this is a carbonyl group, no? So electron transfers here, positive charge, here negative charge. So here in this point, this is a polar in nature. See, double bond O, it's a polar in nature. Oxygen, it is more electronegative. You know very well. So, oxygen, it is more electronegative than carbon. So, it causes what it is permanent dipole moment. Okay, this is a polar in nature. This is a permanent dipole moment. Dipole moment. Right. Now, here in this pulls, which is pulling that electron. Dipole moment that pulls the electron density away from carbon and towards to that oxygen. Away from the carbon and towards to that oxygen, because oxygen is having more electronegative charge, right? So this is del plus and del minus, which is del plus. Carbon, it is del plus, and oxygen, it is del minus. So partial positive charge, partial positive charge, it is nothing, electrophilicity. So partial positive charge on carbon, more powerful electrophile, and increase the reactivity on the nucleophilic addition reaction. That is what all these points I have given. So whenever nucleophilic addition reaction comes, these are all the ideas, tricks for you to identify the answer. Hope you got the clarity. So reactivity is directly proportional to electrophilicity. Electrophilicity, it is nothing, partial positive charge on carbon, and reactivity is indirectly proportional to steric hindrance, many carbon molecules together with that keto group, right? Okay, now in this point here, CH3CHO, as these points only will help you to identify which is the correct option. Okay, so according to that, formaldehyde, because here there is no steric hindrance, it is HCHO, free hand movements. So naturally this will be number one. Formaldehyde will be number one. Now this is that one, and the second one whom you will give that. Here hydrogen is there, no, so naturally you will give that importance for this. Okay, so alpha hydrogen also we can say in that way. So you will give that importance number two. Now, of course, the steric hindrance, both the side two soldiers are available. So steric hindrance, too much of crowded. So you cannot go for that reactivity order. So naturally what it is, this will be last. So this is 3. Now, which is the correct option? 2, 1 and 3. So 2, 1 and 3. So this is the correct option. Hope you got the clarity. Why do we go for this option? According to these tricks, that is what purposely I have given a clear idea about reactivity order. So this is NAR, it is nothing, nucleophilic addition reaction. So Grignard reagent is also one of the nucleophilic addition reaction, right? So these are the points. I hope you understand this question, and which is the correct option? Option B is the correct option. Come on, let's go to the next question. H2 phenyl group, which is attached CH2OH. It reacts with formaldehyde along with TSOH, that is para-toluene sulfonic acid. Actually, this is a dehydrating agent. Along with, while heating, you are getting the product A. Now we have to find out the product. See, formaldehyde reacts with, actually what it is, CH2OH, that means alcohol. Primary alcohol reacts with formaldehyde. So that is the small trick for you to understand. I just bring it to your notice. Here formaldehyde, HCHO. So HCHO combined with the 2 molecules of alcohol, you are getting acetal. That's all. This is a trick for you to understand. Removal of water. So para-toluene sulfonic acid, it is used because to removal of water, dehydrating agent. So that is what here. Very simple way for you to understand. So formaldehyde combined with TSOH, para-toluene sulfonic acid, removal of water, you are getting what it is, acetal. So this is the reaction, general reaction. Okay, now in this point, what they are mentioning, CH3, CHOH. Okay, let me draw the structure for you. CH3 here in this point, CH3, CH2, here OH, here CH, here in this CH2 phenyl group which is attached over here. Here CH2, here OH, and then reacts with what it is, formaldehyde, HCHO, along with the TSOH, that is para-toluene sulfonic acid. While heating, you will be getting what it is, the product. Okay, now here I just give a small trick for you to understand. See, in this point here actually, C double bond O, here one hydrogen, here one hydrogen. Okay, now in this point here, I just draw the structure for you. So this oxygen, this hydrogen, this oxygen, and this hydrogen. So you are releasing water molecule. So that means here how many carbons will be available here? Here 1, 2, 3 and 4, here 5 and this is 6, right? Okay, so you will be getting that cyclic compound here in this point, here CH3, this point here CH3, no. So this point here CH3 and next one what it is, this point, the second carbon here CH2, here phenyl group which is attached. Right? Okay. Now here oxygen is available. Now here one oxygen, here one oxygen. Oxygen still alive, right? So here one oxygen and here one oxygen, and both combined with what it is, carbon, and here what it is, hydrogen. I hope you got the clarity. How do we go for this? See, this is very simple. Aldehyde combined with primary alcohol. So you are getting what it is, acetal. That is the trick. You just bring it here. And one more point, key point they have given, removal of water. That is dehydrating agent we are using. What is the dehydrating agent? Para-toluene sulfonic acid, also known as TSOH, right? Now in that, see here 1, 2, 3 and 4, 5, here 6. That is what here 1, here 2, this point. Here actually, yeah, this point, right? So 1, 2, 3, 4, 5 and 6. Yes, you got it now. So you are getting, this is the compound, this is the product what we are receiving. Hope you got the clarity. Come on, let us check which is the correct option. Okay, now in that option, pH, CH, CH2 pH only it will be coming, right? CH2 pH. So here there is not that way. Okay, option A, it's wrong. Option B, it is CH2, still it is alive in this. Yes, CH3, yes. Here, CH2, here I just mentioned, of course, cyclohexane only, no. So naturally CH2 will be there. Here one hydrogen, here one hydrogen. That is what I just mentioned here, right? Here CH2, right? So option B is the correct option. Option B is the correct option. And option C, here CH3, CHPH. No, this is not, we did not bring in that way. Right, this also, it is actually what it is placed as changed. So this also it's not correct. So which is the correct option? Option B is the correct option. See, this is not like what to say, mind-blowing question. It is very simple if you know the trick and if you know the concept very well. Surely you will sail the boat very correctly and perfectly. I hope you got the clear idea about this point and this. How do we solve this question? Come on, let's go to the next question. C double bond O, CH2, CHOH, phenyl group which is attached with the iodo group OCH2, CH3, OCH3, combined with the basic medium KOH, strong base, and reacts with hydrolysis, water hydrolysis, and when heating, you are getting how many products, total number of products obtained in the above reaction they are asking. Right, now this is actually very simple trick I would like to give you. Generally, ester combined with strong basic medium, you will get acid plus alcohol. Now, in this trick, how do we identify here ester? Actually, at this point, it's a very big compound, right? So here, what do you observe? In this alcoholic group, it is available. It is very strong, more strong in basic medium. So it will not react with basic medium. Of course, this is plus I effect and this is minus I effect, right? This is plus I effect and this is minus I effect. Of course, this is also plus I effect only. So these will not affect by OH minus ion. Right now, here, this is KOH and here HOH. So, which will be affecting? That means ester, here is the ester, COOC, right? Is there, right? So this is ester group is available. So that means here the bond breaks over here. Actually, here H and here OH. So this is an acid. This is actually what it is, acid. And this is what it is, alcohol, ROH. Here tertiary carbon is available. So tertiary alcohol. Right. So tertiary alcohol. I hope you got the clear idea about that. See, instead of explaining that full complete, if you know the exact concept and trick, easily you can crack within a second, right? I hope you got the clarity. So acid plus alcohol, how many products? 2 products only. Hope you got the clarity. So ester with basic medium along with the hydrolysis, so you will get acid and alcohol here in this point. So what is the product you will be getting? CH3 thrice COH plus here C double bond O is there, no, here OH, right? And then here what it is? CH2 CH here OH, it is not affected by basic medium. And of course here what it is? Phenyl group, a very big family, joint family like it is. Okay, here iodo group, here OCH2 here CH3, right? And then here OCH3. See, very big compound has broken into 2. Right. So this is all one group. OCH. Here only I just mentioned, right? See, here only OH, that is acid group, COOH. And here alcohol group, acid and alcohol. I hope you got the clarity to find this answer. Exactly. You just observe the question. Easily you will find the answer unless until if you know the concept and the trick. If you are analyzing that way, easily you can crack that sum. Right. Come on. Let's go to the next question. Reaction condition would you choose to bring about the following conversion? See here benzene along with acetol. Okay. So this compound which is attached with benzene, now you are getting the product actually what it is? Benzaldehyde and ethylene glycol, dihydric alcohol and aldehyde. So you are getting the product what it is? Aldehyde. This is actually aldehyde and alcohol. So 2 products you are receiving. So in that, which is actually which reagent we are using to get that product? That is the question. Now here, the first one, lithium aluminum hydride, completely what it is? Reducing agent. And this is what it is? Acid catalyzed. Option B, it is acid catalyzed. Why? Because it is H2O along with H2SO4. So water hydrolysis, like acid hydrolysis. Right now, third one, it is basic medium. This is acidic medium. This is basic medium, H2O with the NaOH while heating. And the last one, PCC, this is mild oxidizing agent. Okay, now which can have that there to react with this compound? See, here lithium aluminum hydride do not have the chance to react with this compound. Why? Because it cannot break that carbon bond, because it has broken that carbon bond, right? So it does not have the chance to break the bond. Whereas here acid catalyzed, it is having that because it is water removal also it is available. So acidic acid strength, it is having that cleavage to bond, so that it can break the bond. Okay, but basic medium do not react with this acetol group, right? And the last one, even oxidation process also, oxidation, even this point also do not react with acetol group. Now, which is possible means actually option B, acidified water, that is acid catalyzed have the chance to break that bond. How it is breaking that bond? Come on, let us check. Here, I just put it ulta for you to understand. Here oxygen, both connected with what it is? Benzene. So like this only now I just put it ulta for you to understand. Right. Now here what it is? First and foremost, water molecule we are adding. So the lone pair of electrons are available. So the lone pair of electrons which is attacking that carbon. Right. So what you will be receiving here? So you will be receiving here what it is? Here OH. So in this point you will get what it is? Here you will get H and here OH. So both the side, and here also you will get a H, here OH. So you will get that compound like this, right? OH, see already O it is there. So OH and here also OH. And here this is benzene, this is benzene connected with both the side what it is? Here OH and here also OH. So you will again you are adding water, I mean H plus ion, that is H2SO4, right? So here H2SO4, right? So what happened here? Removal of water. So removal of water, H2O, right? So here H2O. So that means CHO, right? So this is completely has gone. So CHO. So what you will be receiving here? Here you will be receiving benzaldehyde, right? Here you will be receiving what it is? Benzaldehyde. CH double bond O, right? So this is benzaldehyde. This is benzaldehyde. And this is what it is, ethylene glycol, CH2, here OH, and here also OH. So this is dihydric alcohol, ethylene glycol. That is what, that is here CH2, here CH2, OH. So what is the main idea to understand this question? Which compound having the chance, which compound having that strength to break the carbon bond? That is the main idea. So to get the answer right now, I hope you got the clarity. Now, which is the correct option according to this? Here, this is the product, means this is the correct option. Which is the correct option? Acid hydrolysis. So acid hydrolysis having the strength to break the carbon bond, as well as it provides that water molecule along with removal of water molecule to receive this compound. Hope you got the clarity to identify this answer. Come on, let's go to the next question. combined with the excess of methyl iodide along with strong base, that is potassium hydride, that is also excess. So you are getting the product what it is. Actually you are getting 81 percentage of yield, that is a product. So what is the product? So first and foremost, this is keto group. Side next group, it is acidic hydrogen is available. So acidic hydrogen completely replaced by methyl group. Come on, let me explain for you. Here this is actually cyclohexanone. So this is cyclohexanone. See here, excess of methyl iodide and excess of what it is, potassium hydride. So this what it is, acidic hydrogen. This is actually what it is, acidic hydrogen is available. Both the side acidic hydrogen, it's ready to lose the proton. So that means actually the transfer of electrons transfers over here. So you will get positive charge. Here if it is positive charge means you will get the negative charge here, right? So this is positive charge, right? So this point positive charge means here both the side you will get negative charge. And mainly they mention what it is, excess. So 2 times, 3 times at a time, it will start removal of 2 hydrogen. So removal of 2 hydrogen this side, removal of 2 hydrogen that side. So this is actually what it is, CH3I. So CH3I, this is actually what it is, minus, and this is plus. So this plus positive charge which will go on attracted towards that negative charge. And the same way, excess n number of what it is, methyl ion, which is going to attract it towards that acidic hydrogen. So removal of hydrogen, instead of that, in that replacing of methyl group. So what is the product you will be receiving? Of course 100%, right? This is benzene. This is benzene. In that what you will get it, both the methyl group will be available. This side also methyl group and this side also methyl group, right? This side also methyl group, CH3. And here what it is, double bond O, same, safer enough. Now here what they are asking the question, that is what is the product, 81% you are healed. So that means a replacing of acidic hydrogen and what it is, substitution of what it is, methyl group. So that means this is the product you will be receiving. What is the product? 2266. Here I will mention the point name of that. So 2266 tetramethyl. So for methyl group it is there. No, so tetramethyl cyclohexanone. Right here this is cyclohexanone. ONE, right? Okay, so which is the correct? Of course, this is option C as the correct. So both the hydrogen, acidic hydrogen, which is replaced by methyl group, and even strong base also it is available. So enolyze, actually there is no chance of enolyze because keto enol you can think about that. But here excess also they mentioned that word, and strong base also they mentioned. So naturally, what is the product? Product C you will be getting. Hope you got the clarity. See, these are all a simple trick if you know that what is the product, what is the reagent, how it is going to react. So that point, see, for that we no need to go for analyzing that mechanism. Right now here, what is the conversion, what is the product? Very fast. In organic we need less time to find the answer if you know the concept thoroughly. That is what I'm giving the trick for you to understand and remember also. So here acidic hydrogen is available. So to replace that acidic hydrogen, you are going to replace that, instead of acidic hydrogen you are going to replace that methyl group. How many acidic hydrogens are there? That many methyl groups will be available because they mentioned what it is, excess, right? I hope you got the clarity. Come on, let's go to the next question. Alcohol group which is attached with cyclohexane and carbonyl carbon, that is keto group which is attached with the CH2 and that is attached with cyclohexane. See, you are having that compound converted to here alkane. Now you see, you just observe here, this is keto group converted to here alkane, right? Now that means you have to check whether how many carbons are available here. 1 carbon. Here also 1 more carbon is available, right? Now this compound which is converted to this compound, so that is 100% what it is, carbonyl compound converted to alkane. That is the matter. Where do we identify? Here. Now just observe that option, Clemenson's reduction, Wolff-Kishner reduction, sodium borohydride, none of this. See here very clearly I can mention you Clemenson's reduction. Clemenson's reduction. Clemenson's reduction, it is an acidic medium, right? So this is acidic medium. Why I'm mentioning what it is? It is Zeton and HCl also, Zeton amalgam, that is Hg also becoming acidic medium, right? I just mentioned very clearly for you to understand. So the next one, what it is? Wolff-Kishner reduction. Wolff-Kishner reduction. So Wolff-Kishner reduction, it is actually what it is, basic medium. Hydrazine, NH2 hydrogen along with KOH while heating. So this is basic medium, right? Basic medium. So what is the main point I wanted to mention here? Acidic medium and basic medium. Clemenson's reduction and Wolff-Kishner reduction. Actually, what is the target? Carbonyl carbon, keto group or aldehyde group. See double bond O, here H, CHO. So this is keto group and this is aldehyde group. Both can converted into alkane. Alkane like this. Right, alkane it will change. So carbonyl carbon, carbonyl compound converted to alkane. So that is only Clemenson's reduction and Wolff-Kishner reduction duty. So it will not affect the OH. Actually here OH is same as it is. You see here, here also OH is there. Here OH still it is alive. It is not what it is broken. So still it is alive. So that means it will not affect the alcoholic group. Why? Because Clemenson's reduction and Wolff-Kishner reduction target, it is only affect the carbonyl carbon and converted to alkane. So here Clemenson's reductions, Wolff-Kishner reduction, we can keep it. Right now, let us check another option C. Sodium borohydride. Sodium borohydride, it is a mild oxidizing agent. What it is? Mild reducing agent. Sorry, mild reducing agent. So mild reducing agent, actually what it is? Reducing agent, what is that duty? It converts aldehyde or ketone. Aldehydes converted to mild reducing agent converts aldehyde into primary alcohol and ketone into secondary alcohol. And same lithium aluminum hydride. Lithium aluminum hydride still more better. That is little more stronger reducing agent. That is also the same duty, only it helps. What it is? Conversion of carbonyl carbon to aldehyde or aldehyde converted to primary alcohol, ketone converted to secondary alcohol. But none of these. Here I wanted to mention a small trick for you. Here 2 carbon is available. So 1 carbon converted to alkane, another carbon alkane only. So that means what is the product you will be getting? Here this is the product you will be getting, right? So here, right, this is cyclohexane. Here OH, yes, it is there, of course. And here carbonyl carbon CH2, right? This part only CH2, it is converted to CH2. Whose duty? One might be Clemenson's reduction or it might be Wolff-Kishner reduction. Another one more CH2, it is still alive. See here CH2, it is there. And the next one only another cyclohexane. See here cyclohexane, it has put it horizontal. I just put it vertical. So 2 carbon, it has to be mandatory. But here what it is, only 1 carbon only it is available. Another carbon absent. So that means how is it possible? This product actually 2 carbon, it has to present, right? So that means this is not the correct option. I mean, this is which is what they have given 3 option also. It's not correct. None of this. Why none of this? Because the product, it has to be like this. This is the product you have to get. Right? You did not get this product. 1 CH2 group totally abscond. Right? You only 1 carbon they mentioned, that is, of course, any one, what it is, Clemenson's reduction or Wolff-Kishner reduction, it's ready to convert what it is, carbonyl carbon, that means keto group into alkane. But here 2 carbon it has to be present, but here only 1 carbon it is present. So totally another CH2O, it is absent. So that means this is not a product. So none of this only is a correct. So which product it might be getting means this is the product. Hope you got the clarity. See, everything, if you observe very keenly, you will get the correct option. There will be a small key point solution. It will be available. Hope you got the clarity. Come on, let's go to the next. Triple bond CH. That is alkyne. Alkyne combined with HgSO4. See here, HgSO4 dilute H2SO4. So you will be getting what it is. HgSO4 and dilute H2SO4. You are getting the product A right now. And the same alkyne combined with the diborane, that is anti-Markovnikov's rule. So you are getting product B. So product A and product B, actually here they are mentioning about differentiated by these. 2,4-DNP, sodium oxyiodide, that is an iodoform test, and sodium metal, sodium bisulfite. Right now, let us check one by one what is the product we are getting. How do we differentiate? Okay, first and foremost, this is dilute H2SO4 along with the HgSO4. You know HgSO4 along with the H2SO4, dilute H2SO4. So this is Kucherow's reaction, you know very well. Kucherow's reaction, right? And one more thing also we can make out, because dilute H2SO4 acid medium, right? So this is actually Markovnikov's rule. We can bring that point also. Markovnikov's rule. Right. Okay. So both the points you can bring it over here. Another one, it is second one. What it is? Option B. This is option A, product, and this is option B. What they are mentioning about? What it is? BH3. It is a diborane, right? Along with the THF and what it is? H2O2, hydrogen peroxide, OH minus, basic medium. Right now here what it is? Anti-Markovnikov's rule. Anti-Markovnikov's rule. Right. Now, what is the product? Let us check. Here, product A. So, this is CH3, C triple bond CH combined with HgSO4 with dilute H2SO4. So, what is the product you will be getting? You will be getting actually CH3, here CH3, C here OH, double bond CH2. Why? Because already I just mentioned this is Markovnikov's rule. Here what it is? Markovnikov's rule. Right now, this is anti-Markovnikov's rule. This is product B. And we are talking about product A, right? So here CH3, CHOH, double bond CH2. You know Markovnikov's rule when we are using what is the product? You will get a secondary alcohol, right? But here alkyne, so that is you are getting in that way. But it will not be quite. This is the intermediate, unstable. So automatically it converted to what it is? CH3, here what it is? C double bond O, here CH3. So hydrogen shift it will take place. So you will get keto group. So the compound A will be ketone. Right now, compound B, let us check because compound B, it is totally different anti-Markovnikov's rule we are using. So this is a terminal, what it is, alkyne, right? CH3, C triple bond CH combined with BH3 along with the THF and H2O2 and OH minus. So you will be getting the product what it is. Here you will get CH3, here CH, double bond CH2, OH. See, this is also intermediate product only. So, here also tautomerism takes place. Why? Because keto-enol tautomerism, this is what it is, CHO, right? Here keto group, here CHO, so that is aldehyde and keto group, keto-enol. So, we are mentioning about what it is, enol. And here also, this is actually what it is, alcoholic group, symbolically. So, here also, tautomerization takes place. So, naturally, what you will receive that actually CH3, CH2, here CH2 and what it is? 1, 2, 3, 3 carbon, right? So, here you will get CHO, 3 carbons, right? So, in that point, what you will get? You will get aldehyde. So, second one, aldehyde. So, in that aldehyde, here you will get keto group. Keto group. So, compound A, it is keto group. Compound B, it is aldehyde. Now, how to differentiate aldehyde and ketone? You know very well. So, that is what. Now, I hope you got that clarity. And one more thing. This is anti-Markovnikov's rule, right? Anti-Markovnikov's rule. Markovnikov's rule. Right. So, anti-Markovnikov's rule, what it is? This is a terminal alkyne. So, terminal alkyne, naturally, you will get terminal functional group aldehyde only. Right. According to this point I'm mentioning. Okay. Now, let us check what are the correct options. I mean, what is the correct option? Here, they mentioned what it is, 2,4-DNP. Actually, 2,4-DNP, both will be answering here. Aldehyde also will be answering. Keto group also will be answering. So, this will not be the correct option for differentiation. They are asking about differentiate now. Okay. Now, here, this iodoform test. So, iodoform test will be answerable only for keto group. Only for keto group. Why? You know, iodoform test, it will be answerable for what it is, secondary alcohol. So, secondary alcohol converted to keto group when it is going for reduction, mild reducing agent. So, naturally, you will get keto group. So, keto group, it will be answerable. Sodium oxyiodide. So, that will be answerable. And the next one, sodium metal. So, this will be the correct option. Let us check another two. Sodium metal, actually, it produces hydrogen gas because aldehyde and ketone. Sodium metal. So, hydrogen gas produces for both. Aldehydes and ketones, both will be producing hydrogen. So, that hydrogen gas it produces. So, we cannot make the difference. And sodium bisulfite, actually, here, sodium bisulfite will be answerable for aldehyde. And it will be answerable for only dimethyl keto group because sodium bisulfite will not react with steric hindrance. It will not react to more number of carbon. Right now, for example, C, here C double bond O, here C. That means only 2 methyl group. Okay, once in a while it will be answerable, but it is not very clearly. Why? Because it is a steric hindrance. It will be answerable, pakka, it will be answerable for aldehyde. Keto group, that too what it is, dimethyl ketone only it will be answerable. But here what it is, you see, here also dimethyl ketone only it is available. But which is exactly answerable means sodium oxyiodide, that is 100% it will be answerable for what it is, keto group only. So this is may or may not because sodium bisulfite, it will, because due to steric hindrance, it may answer sometimes. So, which is the correct option? Because the correct option they have given. So, the correct option it has given, that is what we are mentioning. So, sodium oxyiodide will be answerable only for ketone. And 2,4-DNP, it will be answerable for both aldehyde and ketone. The sodium metal, why we are mentioning? Because it produces hydrogen. Both it will produce hydrogen. Aldehyde also, sodium metal, it reacts and it produces hydrogen. Whereas, keto group also, it will react and it will produces hydrogen. So, we cannot take that for differentiation. And sodium bisulfite, it will be react with aldehyde and you will get white crystalline substance. So keto group rare. It is like why sodium bisulfite do not react with the keto group, because it is a steric hindrance, it is available, so it will not go and react. So which is the correct option? Sodium oxide, that is keto iodoform will be answerable for ketone, right? I hope you got the clarity. Come on, let's go to the next. Cyclopentanone reacts with HCN, you are getting the product A. Right now here lithium aluminum hydride, it is a reducing agent, you are getting product B. That is combined with NaNO2 plus HCl, that is nitrous acid you will be getting. So that will be reacting with compound B, that is product B, you are getting compound C. Now which is the final answer? C, right? Now this is actually one trick I would like to give you here. See, this is 5-membered carbon, right? 1, 2, 3, 4, 5. Cyclopentanone, right? Cyclopentanone combined with HCN, 1 carbon extra, cyanide carbon extra. So, number of carbon will be increasing. So, in that way, small trick. Like, see, some degradation point also will be available. So, removal of carbon. Here, addition of carbon. You please remember that trick so that it will be easy for you. So, here, everywhere, it is 5 carbon only. But here, 6 carbon. Right now, let us check even here also. 6 carbon, here also 6 carbon, here also 6 carbon. Now here also 6 carbon. Now which is the correct option? Come on, let us check here. See, actually this is nucleophilic addition reaction, right? So here H plus ion. See, this is what it is? Cyclopentanone, right? So this is cyclopentanone. This is cyclopentanone, right? Combined with H plus ion. First it will go for H plus ion only. So the lone pair of electrons which will attract towards H plus ion. So naturally what you will get? You will receive this, what it is, this double bond O it will be, but hydrogen it will go and attach, so you will get positive charge. So in that now what happened? See, this point which is going to transfer. So here what it is, Cn minus ion, it is ready to attack this carbon. Now you see here, this is positive charge. Now this has become a positive charge. Now this has become a positive. This Cn minus ion which is going to attack over here. So what you will be receiving here? So the double bond breaks. See here, no, 5-membered. So here what it is? Here you will get what it is? OH, right? And here carbon which is triple bond N, because cyanide, no, it is triple bond N. Now here what it is? Reducing agent we are using. What is it reducing agent? Lithium aluminum hydride. So lithium aluminum hydride, when it reacts with the cyanide, it is converted to amino group. So what you will be receiving again? So this is same like 5-membered ring. Here OH. Here what it is? CH2. NH2, because hydride reducing agent, no, hydrogen is available, right? Plenty. So naturally this point which is converting, CH2 NH2, CH, what it is, lithium aluminum hydride 4, it is there, no, so naturally you will get amino group. Right now next one what you will be receiving, so this is sodium nitrite, NaNO2 along with HCl. So I've already mentioned what is the product you'll be receiving here. HONO, that means here HNO2, nitrous acid you will be receiving from this point. So nitrous acid reduces this amino group, and here actually nitrogen gas will be relieved from here. So what you will get the product here, you will be getting that product. See here OH you will be getting, here CH2 you will be getting. So CH2 will be positive charge. Why? Because now amino group has relieved what it is, nitrogen gas. So this has come out, this has gone away. So naturally what you will receive, so automatically you will get positive charge. This is relieved, means naturally you will get positive charge. So this positive charge, now carbon number we can count here. So carbon number, this is 1 and this is what it is. Here you will get 2, here you will get 2 and here 3, here 4, here 5 and here 6. Right now you will, due to this hydrogen, no, so you will be getting like this way, right? So here 6 carbon will be available. Right. So here what it is? Double bond O and hydrogen will be there. But actually this is positive charge now. So naturally this will take over by this, and then finally you will receive that product. What it is? Cyclohexanone, 1 carbon extra. So this is a double bond O. So what is the product you will be receiving? Cyclohexanone. That is cyclopentanone, no. So this is cyclohexanone. So that is what I just mentioned, a simple trick. Anyway, this also 6 carbon is available. But when it is connecting to that point, as we are mentioning about all these reactions of compound A, compound B, compound C. So along with what it is, HCN, lithium aluminum hydride, it is completely reducing agent, and this is actually what it is, diazo compound. When we are using those, that time we will use NaNO2 HCl, that is nitrous acid. Right now what is the product finally we are receiving? We are receiving what it is, cyclohexanone. See this your option 100%, it is like that only, because number of carbon will be increasing. So number of carbon increases means you will be getting one more carbon extra, so 6-membered ring. Like that you will be getting. Hope you got the clarity. Come on, let's go to the next question. 10 more questions. Let us check. I hope you understand all these questions, and thank you for watching.